We will solve this today's LeetCode problem. So here we have given LeetCode media one score after flipping matrix. So here we have given m cross n binary matrix grid, a move consisting of choosing any row or column and toggling each value in that row or column. That means I will choose a row or column and toggle every 0 to 1 and change 1 to 0, right? And every row of the matrix interpreted as a binary number, and the score of the matrix is sum of these numbers. So every row of the matrix interpreted as a binary number, and the score of the matrix is sum of these numbers, right? And return the highest possible score after making any number of moves, including zero moves. So if you see here, we have given example that this is a binary matrix given here, and we need to modify it to make this as a highest possible score, right? So here score is given, the score of the matrix is sum of these numbers, right? So this is a binary number, so we need to form a number which is made by these binary numbers in a particular row. So after modifying it, it becomes this 111 and 1001 and 111. So after seeing this one, the first row denotes 15 number, the second row denotes 9 number, and the third row denotes 15 number, which is 39 number, right? So this is the example which is given, right? And uh, so this is the example limit to given. So here, if you see here, that we need to maximize this number anyhow. It means I need to make this binary numbers as one at the maximum one at the positions, right? The uh, one thing which I uh, which everyone should get, that we need to anyhow anyhow maximize the possible score, right? Okay. So if you see here, this the binary numbers beauty is what, if you see the position, right? If you see 1001, so this 2 to the power 0, right? So we have we iterate in binary number from the left to right, from right to left, right? So this is something 0 1 2 3 4. Okay, so this is 4 3 2 1 0, right? This is the iteration we use for this 1001, right? So if you see here, 2 to the power anything, suppose 2 to the power 3 is greater than 2 to the power 2 always, right? So this 1001 and this 1000, whenever we increase any bit number, whenever I increase a bit by 1, so this will be always be greater than this, except that this will be this 1001, this will be always be greater than this, accepted. Why? If you see this here, this 111 maximum value 1, so this value is the maximum value for this much bits, but this is still small than this one. Still there is only one, and after there is all zeros, still this is greater than this, right? So this is the same thing which we need to do here in this matrix. The same thing which need to apply, that if 2 to the power 3, this 2 to the power 3 value is always be greater than 2 to the power 2 plus 2 to the power 1 plus 2 to the power 0, right? This will be always be greater than this. The same thing which we apply here, that because we need to maximize the possible score now, so I need to anyhow put the one at the starting position. I need to anyhow put the one at the starting position, which is at this zeroth location. J is equals to 0 at, if you see from left to right, then j is equals to 0 in this matrix, this column I is equals to 0 and j is equals to 0. The at the first column, first column at the first column, I need to anyhow make make 0 make 0 as 1, or maximize the maximum one, maximize the count of ones right? At the first column, that means this 111, this 011 part, the j is equals to 0, j is equals to 0. I need to anyhow maximize the count of ones in the first column. This is how I need to define, right? So if you see, I need to anyhow, from starting from the first to the last column, I need to anyhow maximize the count of one starting from the first part, right? So this, that's the whole logic. If you see, that's the whole logic, that because this two here, this is a binary number, so we will think in binary, that how we will maximize this. So if you see this, if you, I make one at the starting position, it means that's the maximum value. If we put zero, so that will not be. If you put zero at this starting point and make all the ones, that's the no point, right? That's the no point. If I make this, if I make this like this, then it is still greater than. If I make this anyhow, and you make this, so this is still greater than this, right? Understood? This is still greater than this. So anyhow you need to make one, and don't worry about all the zeros which is in the left side of one, right? So you need to start making the first column. You need to start worry about the first column only, and maximize the counts of the first columns of every row, first column of every row, right? So that's how I need to maximize it. So how we will we maximize it, right? So if you see here, we need to change all 0 to 1 and all 1 to 0, and we need to worry about only the first column which is of every row. We need to worry about the first column of every row, right? So what we do, if the first thing what we check, if, so if the first column is 1, then it's good, then it's so good, then it's good, then we will, we need not to do anything, we need not to do anything. Why? Because if the first column is 1 and later on we change some 0 to 1, then this one should also be 0, because here is written we need to change all 0 to 1 and all 1 to 0, and we can't afford this one to make 0, right? So if the first column is 1, then we don't do anything simply. Otherwise we need to make this 0, which is not optimal, right? Which is not affordable to us. So if the first column is 1, then we don't do anything. And if it is not, and if it is not 1, then I need to change it to 1, and change all 0 to 1 and 1 to 0 in that particular row, right? To make it, to make the first column 1, I need to change it all 0, because here is written that if I want to change any value, I need to change all 0 to 1 and all 1 to 0. So this is the whole concept which we use, right? Simply. So this is the whole, and after that, this is the process which we do in row wise, right? Which we do in row wise. So the first thing, if you see here, if you see here 0 0 1 1 1 0 1 1 1 1 0 0, what if I if you see here, to make this dry run, if you see here, to make this dry run here, so here in this, if the first column is not 1, we have changed it to 1, and all 0 to 1 and all 1 to 0 simply, right? And if first column is 1, we don't do anything. So this is similar thing, right? And again, this first column is 1, so I don't do anything. So this changes to this. Now if you observe, when we can also change column wise, right? So if you see in the column wise, so the maximum value, how will it occur? So we need to find the maximum value. In column wise, what we will see, in column wise you see the maximum number of counts in column. Now for columns, we need to check the maximum number of counts. We need to make the maximum number of counts of one. Why? Because if you observe this one part, this one part, if you observe this as a one part, so this one is 2 to the power 3, this is also 2 to the power 3, this is also 2 to the power 3. So if you add like this in vertical direction, so this 2 to the power 3, this 2 to the power 3, this 2 to the power 3 will be added again this 2 to the power 2, this 2 to the power 2, this 2 to the power 2 will be added, again this is added, and whole becomes a maximum possible value, right? So this is what this is 0 1 2 3, so these are 2 bar 2 4, and this is what is this 3 uh, 8 plus 4, that is 12, right? Again this is uh, 1 plus 2 is 3, 3 plus 8 11, yeah 11, and this is again same 12, right? So this becomes 12 11 plus 12 11 12. So this is 1 2 1 2 to the 4 1 5, and this becomes, you can do the calculation, right? So this is 35, right? And if we add in vertical direction, so what it is, so firstly the first position, which is equals to 2 to the power 3, which is 8, so 8 here 24, this is 24 plus 2 to the power 2, 2 to the power 2, which is 4, again 4. This is 1, 2 to the power 2, which is 2 to the power 0, 2 to the power 1, so it becomes 2, and now the first position is 1. So if you add this will give me 28, 30, and 31. Something is missing. Let's see what we have done wrong. So this is 1 plus 2 is 3, 3 plus 8, 9, 10, 11, correct. 0, 1, 2, 4, 4 plus 8 is 12. Something is missing. What we have done wrong? 8 is a 12. It's a 24. Okay, this should be 8, right? Because there are two ones, right? There are two ones, so this should be 8, right? So if you observe, this is again a summation to 35, right? So if you vertically add like this or horizontally like this and sum like this, that would be the same, right? So I need to anyhow maximize this number of ones at a specific position in columns, so that after summation this should be the maximum. So I need to make the maximum number of counts of one in a particular column, right? So for that, what we need to do, we need to iterate in column, iterate in particular column, and count the number of 1 and 0 after this value, after this particular approach, after this after changing all the things in from zero, from row to, then we will change this 0 to 0, right? Now the maximum thing, the maximum of 1 or 0, which will we get, we will need to change. If suppose this 0 number of count of 0, if count of 0 if count of 0 is greater than count of 1 in that column, then I need to change all the 0 to 1, because I need to for making maximum, I need to make the maximum number of 1. So then then I will change all 0 to 1 and 1 to 0, simply. Why? Because I need to maximize the specific maximize the number of ones for a specific particular column. So I need to change all 0 to 1 and 1 to 0, right? And if it is not, then we will don't do anything. Otherwise otherwise we will leave it, right? And after this, we will simply move to every row, and after this, after iterating in all columns, we will again iterate in this binary matrix, binary grid, to calculate this value, that 15 9 15, right? Grid to calculate, to sum for summation, for summation of the values, right? So that I can get an answer, and that will be my answer, right? So this is the whole approach we will get, right? So the whole gist is of this question, or the solution is, that you need to maximize the position of the last bit, which is this 1 1. The first column you need to maximize. That's the whole point of binary. So if you, whenever you get a binary thing, you need to always remember that this need to be maximized always. if you get to maximize the in the binary, right? So the first bit should always be maximum, right? So let's see how we will implement this, right? So this is the zero dot size. Now from here, I need to first thing what I need to do, I need to check the first column is one or not. If though, if that is one, we will don't do anything. Otherwise, we need to change all the zero to one in that particular row. So let's start, right? So we will start iterating that. Now this is on your implementation, that how will I implement, right? So we will check that if j is equals to 0 and this grid I j is equals to 0. If both is 0, it means I need to change all over. uh, so okay, if this is 0, so if this is 0, and so first thing we need to check in starting that this, if this grid I and 0 is equals to 0, it means I need to change all the grid I to 0 to 1 and 1 to 0, right? So what will I do? I will simply uh, what I need to do, I will simply check here that if this is 0, I will make a boolean value here. I will make a boolean value f 0 and make this boolean value as a true. Now, if my boolean value is true, it means I need to change all the 0 to 1 and all the 1 to 0 in the next part. This from 1 this part, because I have already checked for 0, and if that 0 is 0, I need to change this to 1, right? I need to change this to 1 also. Now, this grid ij should be changed to the inverse of that. If this is 1, then this will give 0, and if this is 0, then this will give me 1. That's why 1 minus grid ij, right? So this is the same thing which we do, right? And this is how we will change all the rows. Now I need to iterate in whole columns also. So I will iterate in column wise. So for iterating in column, I will start from column and iterate in row. So if you observe, I have iterating in column and start iterating in row in the second loop, right? This is how you iterate in column, this is how you iterate in row in the first part, and this is how you iterate in column. Now what I need to check, I need to make the maximum value of 1. Maximum value of 1, I need to make the maximum value of 1. So for that, I need to make a variable count for calculating the number of ones and the number of ones and number of zeros. So for that, I just calculate grid ij. So if this is 0, this will not get effect to the count. If this is 1, this will increase it, right? And now I will check whether this count is greater than, sorry, this count is less than n minus cnt. Why n minus cnt? Number of rows is here, and if we minus the number of count of ones, so it will give me number of count of zeros. And if it is greater than, it means I need to change the whole row to 0 to 1 and 1 to 0. So this is how we will do. I will change the same, make the one same thing, 1 minus grid ij. If the number of rows is greater than number of 1 as is less than number of zeros, then I need to change it, right? So I will call another loop and change this to this. So this is how we will calculate. Now what I need to do, if I change this, now at simply I need to start again iterating in this binary grid and change this 0. I need to calculate the max sum for this. So this is I plus plus, and I need to take a variable for summation answer. Now what I need to store this. So the first thing which is will be there is, what will you add? J is equals to 0, but here this is, it started from j is equals to 0, but it is at the position third position. At starting this is 0, but it is at the position of third. If you see the first example, the first position is 1 here in this example 1. This 1 is here at third position. If you see, if you see from left to right, right to left, but at if you see from left to right, it is at 0. So we need to see the position from right to left. So we need to add this like m minus j minus 1. M is total number of columns, j is that position, and minus 1, right? And this is how we will add all the grid. So one thing is here, if the grid ij is 1, then only we will add it. If it is 0, it will not contribute to my answer. So ultimately it will be written as the answer. So let's run this. uh, it's taking time, I don't know why. Okay, so something is error happening here. Grid ij. Okay, so this should be 1. So this should be 0. Yeah, we have passed the case. Let's submit it. Yeah, we have successfully submitted it. So if you see, what will the time and the space complexity? So time complexity will be, okay, that will be, first I need to iterate in O of n into m, right? Again I need to iterate in O of m into n, that is again O of n into m. Now again I need to iterate in O of n into m. So that will be O of n into m 3 times. So that will be 3 into O of n into m. That will be ultimately equals to O of n into m. And the space complexity, so we are not taking any extra spaces, we are making changes in the given input. So that the space complexity will be O of 1, right? So this is the time and the space complexity. Now if you observe here, just for implementation purpose, I also told you that either you sum it accordingly to row, or you can also sum it in vertical direction like this, to add 1 1 1, this 1 1, this 0 0, this 0 0, right? And that will give the same summation. So instead of taking this as an extra loop, what we can do, we can just change it to here, where, okay, I also told you something. Okay, just we can change it to here. Why? So if you see here, and also I told that I need to take the maximum value. So if count of 0 is greater than count of 1, then we will need to take a count of 0 instead of count of 1, right? And if the count of 1 is greater than count of 0, then we need to still take. So we need to take the maximum value of the count of 0 and the count of 1. So for this, if we, instead of doing this, instead of changing this 0 to 1 and 1 to 0, if I just calculate the max value of cnt and n minus cnt, don't you think this will give me number of ones? And instead of, and what is, this should be here, and how many times this one will be occurred, this maximum time, right? In this row, how many times this occurred, this maximum time. So this will be mx into, if you got confused, let's analyze it again. That what we are doing, we are summating some we are doing summation of every, for a particular column, every column. So for every column, this one is at 2 to the power 3, right? And now 2 to the power 3, how many times I will submit, how the number of 1 is present. So in this case, 3 is, number of 1 is 3 times, so 8 0 24. So for what we do here, so this loop is not needed anymore, right? This loop is not needed anymore, and we will just do this int mx max cnt. So this is mx will give me number of 1 in that particular column. This will give me that particular position, that 2 to the power 3 type, and mx will give me number of 1s, and that will be added in my answer and return answer. So let's see if this works. So we save this for loop again to run this, and calculated in this again, right? Let's submit it. So this is just an optimization for implementation, and that will also work here, right? Don't go on this, that previous was 100%, now this is 54%. So don't go on this, this is just a uh, uh, Don't ignore this. This is lead code something. This is calculated from of many factors, not only on solutions. So this is how we will solve this problem, right? So from here we have gone to 2 into n into m, right? So that will overall O of n into m. So that's the overall time complexity. Hope you understand it. And if you understand it, just write on comment that you understood, so that I know that how many of you really understanding my solutions and the approach which I have was trying to understand you, make you understand, right? So just write in comment that you understood it. Thank you so much. Bye bye.